Welcome to the next installment of my video lecture series for microeconomic principles. In this particular video lecture, I'm going to be taking a look at a potential test problem that can occur on test number 3. This has to do with uncertainty and risk, etc. So the question is, use the below figure to answer the following question. An individual is offered a job with the choice of two compensation packages, $40,000 a year versus a 50% chance of making $20,000 per year and a 50% chance of making $60,000 a year. Calculate the expected value and expected utilities from the two compensation packages. Which package will this person select and why, and what does their choice say about their risk preferences? So taking a look at this, if the person is guaranteed an income of $40,000, we know that the expected value of that compensation is going to be $40,000. So we're assuming they're not going to get fired during the year, or there's not going to be any issues, that they work for the entire year. So the expected value is going to be $40,000. Now for the other one, we have to weight the outcomes and the payoffs by the probabilities that they occur. So we know that they have a 50% chance of making $20,000 a year. So their expected value is going to be that probability, 50%, multiplied by the $20,000. And we add to that the 50% chance of them making $60,000. And that should be a dollar sign, not an and sign. So if we multiply 50% times 20,000, that gives us $10,000. And if we add to that 50% times 60,000, we get $30,000. So we see the expected value of that payment scheme where there's a 50% chance of making $20,000 and a 50% chance of making $60,000. The expected value of that payment schedule is going to be $40,000. So you can see here that the expected value of those two payment schemes is equal to one another. So we want to calculate the expected value. The only thing we have to do there is basically we're going to do this same calculation right here, except instead of the 20,000, we're going to convert that to the utility. So we can see that a income of $20,000 will yield 43 units of utility. So I can put 43 in place of the 20,000, and then if I go to 60,000, up to the utility that's associated with that with this curve, that gives me 85,000. I'm sorry, not 85,000, 85. So 50% times 43 gives me 21.1, .1, 21.5. And 50% of 85 is going to give me 42.5. So 50% of 43 is 21.5, and 50% of 85 is 42.5. And that will yield to me, adding those together, 63.2. So we have an expected value of that payment scheme where we have a 50% chance of making $20,000 and a 50% chance of making $60,000 is 63. I'm sorry, it's 64. Come on. It's early in the morning here and I'm having some difficulties here. So adding those together, we get 64. What's the expected value of a guaranteed $40,000? that is equal to 70. So this is the expected value of that payment stream where it was a 50% chance of $20,000. Redo that. And a 50% chance of $60,000. So the expected utility of that is equal to 64, while the guaranteed salary, the utility associated with the guaranteed salary of 40 is going to be equal to 70. So because the expected utility of the guaranteed 40,000 in income is higher than the expected utility when there's probabilities associated with the outcome, this individual will select the guaranteed salary of $40,000. So this individual would be considered risk averse because these two payment schemes that they can get, the guaranteed 40,000 versus the 50% chance of 20,000 and the 50% chance of 60,000, the expected value of those two is equivalent to one another. They are both $40,000. But because they chose the certain outcome of 40 in that scenario, means that they are risk averse.